wondered why ice floats on water? It is because ice forms a hexagonal crystalline structure. Lining up the molecules in this pattern takes up more space than having them jumbled together in the liquid form. And because the same mass of molecules takes up more space when frozen, ice is less dense than liquid water, making ice float. Today we are going to see the 7 crystal systems. Crystal systems occur as a result of the variations in the parameters of the primitive unit cell and their possible centered variations. Let's see the 7 crystal systems in detail. First, the simple cubic crystal system. All the axial distances A, B and C, they are equal. A equal to B equal to C. The angles, that is the axial angles, alpha is equal to beta is equal to gamma equal to 90 degrees. The second crystal system is the tetragonal. 2 of the sides A and B are equal, but it is not equal to the third side C. The angles alpha equal to beta equal to gamma is equal to 90 degrees. The third one, orthorhombic crystal system. None of the edges are equal. A is different from B is different from C, but the angles alpha, beta and gamma are all equal to 90 degrees. The fourth type is the hexagonal crystal system. A is equal to B but not equal to C. The angles alpha equal to beta equal to 90 degrees and gamma equal to 120 degrees. The fifth one is the rhombohedral crystal system. The distances A equal to B equal to C and the angles alpha equal to beta equal to gamma, but they are not equal to 90 degrees. The sixth one, the monoclinic crystal system. 2 of the edges A equal to B but not equal to the third edge. C is different. And in the case of angles, alpha equal to gamma equal to 90 degree, beta not equal to 90 degree. The last crystal system is the triclinic crystal system. None of the angles are same and none of the angles are same and they are not equal to 90 degrees. The edges A not equal to B not equal to C. Now we have a column for crystal systems, their axial distances, axial angles, the possible types of unit cells and their examples. First one, the cubic unit cell. We have already discussed the axial distances and axial angles. The possible types of unit cells are primitive, body centered and face centered, and you know what all those means. Examples are KCl and NaCl, potassium chloride and sodium chloride. The second one, tetragonal. The possible types of unit cells are primitive and body centered. Examples, stannic oxide and titanium dioxide. Third one, orthorhombic. Possible types, primitive, body centered, face centered and end centered. Examples, potassium nitrate, barium sulfate. Fourth one, hexagonal. The only possible type of unit cell is primitive. Example, magnesium and zinc oxide. Fifth one, trigonal or rhombohedral. The only possible variation is primitive. Example, calcium carbonate, mercuric sulfide. Sixth one, monoclinic. Primitive and end-centered are the possible variations. Monoclinic sulfur and sodium sulfate decahydrate are examples. The last crystal system, triclinic. The only possible variation is the primitive. Example, potassium dichromate and boric acid. Now we can see the variations of all the 7 crystal systems. First one, the simple cubic crystal system. The primitive, body centered and face centered is shown. So 3 altogether. For orthorhombic, primitive, body centered, end centered and face centered, 4 of them. Here 3. And in the case of tetragonal, simple and body centered, that is the primitive and body centered. Monoclinic, again primitive and end centered, so total 4. And lastly, triclinic, hexagonal and rhombohedral, only the primitive ones are possible, so 3. So now the total comes about 14. So this is how you have the 14 crystal lattices or the Bravais lattices that we mentioned in the last class. This is all for today's class. Have a nice day. Thank you.